Okay, in this video, we're going to look at states of matter and particles, part of the 7G unit. The aims of the video are to look at how solids, liquids, and gases are different from each other and what the particle theory of matter is. So all matter, or we can think about all matter as one of three states of matter. Okay, those states of matter are solids, liquids, and gases. Okay, we can see from the pictures examples of materials that are in those three states. In terms of properties, the three states of matters have very different properties to each other. If we think about solids and think about the behavior of solids, they do not flow. Okay, they don't move, they don't change shape, they stay in one place unless they're pushed or pulled, and we can't compress them. So to compress them means that we can't make the volume of them any smaller. If we think about liquids, liquids change shape, they flow. If we put them in a container, they take the shape of the container, but they don't change volume. Okay, we can't easily compress a liquid. And then for gases, gases do change shape. They also change volume. They spread out in all directions. So if we think about a room with air in it, the air spreads out to fill the whole room. Okay, and they can be compressed into smaller volumes. So we need to think about why they have these properties. Okay, and we can use the particle theory to explain the properties of the solids, liquids, and gases. So we're going to start by thinking about solids. If we could draw a diagram of a solid and the particles in a solid, this is what it would look like. Okay, the particles are all very close together. They're held together by strong forces of attraction. Okay, that sticks them together. And the particles can't move around each other. They can't move over each other. All they can do is vibrate or wobble backwards and forwards. Okay, and the warmer it gets, the more they vibrate. If we look at this picture, we can see if we put a solid into a jar, it wouldn't take the shape of the jar because the particles are held closely together by these strong forces of attraction. Okay, keeps them in a fixed state. For liquids, if we draw the particles for a liquid, they're more randomly arranged. This time the particles, although they're close together and they're held together by fairly strong forces of attraction, they can move past each other. And this means that a liquid takes the shape of the container that it's in and it can flow from place to place. But because the particles are close together, we still can't compress it. There's not much space between the particles to allow us to compress that liquid. And then finally, for gases, if we draw a diagram of the particles in gases, they look a bit like this. They're spread out, they're far apart from each other. They've got weak forces of attraction between the particles, which means that the particles don't stick together and they can move around in all directions and they can spread out to fill a container. And we can compress gases, as this diagram here shows, because we can make the particles get closer together. Okay, so if we put them into a syringe like we've got on the diagram here, we can press that syringe, we can force the particles to be closer together and compress the gas. And if we did that under enough pressure, we could actually turn that gas into a liquid. So in summary, we need to know that all matter exists in three different states: solid, liquid, or gas, and that the different states of matter have different properties, and that those properties are determined by their particles.